We'll go to the next topic, last topic of module 2, that is called as the Tower of Hanoi problem. In the problem of Tower of Hanoi, there will be three poles, that is A, B, and C. Pole A is source pole, contains n discs of different diameters and are placed one above the other such that larger disc is placed below the smaller disc. Now all the discs from source A must be transferred to destination C using the pole P as temporary storage. So this is how we will be defining the Tower of Hanoi problem. There are some conditions that we have to see or we have to take care. There are two main conditions. Only one disk must be moved at a time. Smaller disk is on the top of larger disk at every step. That means only one at a time only we can move the disk, and always we have to take care that while we are moving, the smaller disk has to be on the top of the larger disk. So let us see the algorithm which we will be moving n disk from source to destination as follows. So there are three steps or three algorithms. So we'll see move n minus 1 disk from source to temporary, move nth disk from source to destination, move n minus 1 disk from temporary to destination. I will repeat the algorithm. Move n minus 1 disk from source to temporary, move nth disk from source to destination, move n minus 1 disk from temporary to destination. Let's understand better by looking into the diagrammatic format. For example, consider the number of disks which is equal to 3, then various steps involved in transferring 3 disks from source to destination as follows. So initial stage we have the poles, source, temporary, destination, and we have the 3 disks. You can see the 3 disks has been differentiated with respect to the color: orange, green, and blue. Orange is having bigger disk, green color is having a little average disk, and blue is a slight small disk. Now we'll see the step 1. That here what we are going to do in the sense from the source we are going to put it on the third pole, that is the destination, that is the small disk. Then we are going to see the second step, that is the average or the smaller one, which is not that big when we compare to the bigger one and or the smaller one, that the second disk will be moving to temporary and the bigger one will be as it is in the source. Now see the third step. What we are going to do in this sense, we are going to move the destination which is having the smaller disk to temporary. We are going to place the bigger disk which is there in the source as it is. And in the fourth step, what we are going to do in this sense, for the source, whatever the bigger disk is there, we are moving it to the end, that is the destination. And we are going to keep the green color disk and the blue color disk in the temporary itself. Now let us see the step 5. What we are going to do in this sense, in the temporary there were 2 disks In the destination, there were one disk of the bigger disk. So what we're going to do is we are going to move the disk from the temporary to the source. Now next thing what we are going to do in this sense, you can see here, source, we will be having the smaller disk as it is placed with respect to the previous step. And then what we are going to do is the green color disk, we are going to place it from the temporary to the destination. Then what we are going to do in the last step is we are going to take the smaller disk which has been placed in the source. We are going to place it from the source to the temporary, from the temporary pole to the destination. So we have reached the target where the discs are in the order. The disc is from the smaller to bigger. So let us see the program, how it will be done. We'll go to the console and we'll see the movement, how it is done. So let's start. Let's start. We will have a variable int count equal to 0. Then we're going to have a function where the return type we're going to make it as void, and the function name we're going to give it as a tower, and we are going to have three arguments, that is the number of disks, which is of int char s, not 3 but 4, and then we have char t, okay, and then char t. That is we have the number of disks which has been mentioned in n, and sdt is the source destination temporary, which we have mentioned as a character. Data type is character. And then what we're going to do in this sense, we're going to check a condition if n is equal to 1. If n is equal to 1, that is if there is only one disk, what we have to do, we have to check all the condition. So in this condition, we have to check that, and we have to write or we have to print it as move disk 1 from, because it is character where it is present, it will be present in the source because we are going to start, so it will be present in the source from %c to %c, because all the poles are being mentioned in characters, comma s, comma t. That is, it will be going only to the destination. If there is only one disk, it will be moving from the source to the destination, and then count plus plus and return the value. Okay, so we have to close the bracket for that, and then if there is more than one disk, then we have to invoke this function n-1 comma s comma d comma t, and then you have to move printf. Just will copy this, same thing, move disk %t from, that is which disk has been moved, and we have to mention here as n, because there is when we are putting more number of disk. So we will see here with respect to 3 only. So we are expecting that we are putting only 3 disks and we see the movement. So we are invoking that function and we are printing it, and then as we have to move to the next disk, then again we have to call until we scan all the disk. So there is 3 disks, we have to scan all the 3 disks. So count plus plus will help us to access the next disk. And we have to close, and then we will be proceeding to the main function, void main, int n, and printf, enter the number of disk, scanner percentage %t and percent %n, and this is invoking the function which we have declared and defined outside the main. These are the poles. So we have already learned about the actual argument, formal argument. It is not necessary that you have to give the same which you have mentioned in the definition. ACB will be specifying it as the names of source, destination, and temporary. Printf, total number of moves. We have to see that also. What are the total number of moves that it is taken? Percentage %t, and count. Let's run and see.